Buenos dias, fuckers. Buenos dias. Buenos dias. Just 10 minutes on Isaac Newton, if you don't mind. The 3 laws of motion from Isaac Newton. Let's say, for example, you've never ever heard of Newton. You're in the kitchen and you see a glass of water. Do you think that glass would move on its own? Or do you think an external force would need to make it move? Otherwise it's just not, it's at rest. And it will stay at rest until something tweaks it, pushes it. Hands up, those who agree. Or those who agree say, aye. Do you need a law for that? Do you think Newton was really clever on that one? An object at rest will stay at rest until nudged. An object that is moving, like in a vacuum, but we don't know that he was talking about vacuums back in the 1600s, do we? Probably not. Probably not. Probably didn't even think of space travel and stuff in those days. So, an object that is at rest, that will stay there until something knocks it. A body at rest stays at rest, and a body in motion continues in motion at a constant rate in a straight line unless acted upon by an external force. How do we feel about that? Do you feel like you're having your intelligence insulted, or you think that is a very good first law to have? I like it. I think we should keep it in case we forget something. A salt shaker, even on the table, you could, Mum, you pass me the salt shaker. Just before she touches it, go, whoa! Newton's first here, that will stay there until you touch it, Mum. It's really, really riveting stuff. Gets me every time. What would we have done without them? How about number 2? You're probably thinking, why has he gone? It doesn't matter. Number 2, the rate of change of motion of a body is proportional to the applied force and takes in the direction in which the force acts. Now, these were taken from the 1961 book, okay? So it might be worded slightly different because they like to change the wording as the times change. Progress. I'm just going to go and grab something, right? Because I think we're going to need a proper demo here. Hang on. All right, let's give it a crack there. All right, here we go. We are. So how many laws do we have there? We had a body at rest, stays at rest. Well, it's at rest now, so it wasn't at rest to begin with. And a body in motion continues in motion, and that's what it was doing, at a constant rate in a straight line unless acted upon by an external force. The external force in this case, obviously, was density and buoyancy. Density and buoyancy. Because this is denser than the medium that it's in, it drops. There's this gravity thing going around as well, but Newton. Hardly reliable. Plus, we know the moon, and anybody who has spent the time with the tide chart since I mentioned it about 3 weeks ago, if you had followed a tide chart for the next 3 weeks and you have common sense and you can do basic problem solving, you too will understand that there is no pattern to be found. The moon and the water, the gravitational force. So what we have here, we're going to go for the second law, which is, again, riveting, fascinating stuff. And I don't know how we could have moved anywhere without these laws. The rate of change of motion of a body is proportional to the applied force and takes in the direction in which the force acts. So let's go to the direction of the force, which, so if I go like this, I did this, try to follow what I'm doing. I'm going to prod this ball like that, and what you'll find is going to go that way. Look, watch. See that? Now, it says the rate of change of motion of a body is proportional to the applied force. So if I apply a little bit more force, you should notice quite a change. Did you see that? Now, the softer I hit it, the less it's going to move. That's what proportional means. So if I give it a good old welly, see, it's proportional to the applied force. Now, if I give it a little tickle, call it a love tap. Look at that. See, again, proportional. And now this is where it can get a little bit tricky, because if I don't want to overload everybody, if I press it, if I go this way, the ball is not going to go that way like it just was. It's going to go in the direction of the force. It's not that complicated. Look, let me show you what I mean. If I go like this, watch. See how it went that way, right? Now, if I go this way, watch. It goes that way. There's never going to come a time when I go like this, that, and it goes that way. This is never going to happen. Can you see what I'm saying? So, they're not that complicated. Some would just say it's just common sense. Laws. But we're all good with laws. We needed those laws. You needed to know that this, if it's at rest, stays. Come back tomorrow, if there's no wind, it's there. But if I do that, Newton, then it's going to hit the flat earth that's on the board. Now we come to one of our favourites. Let me just press pause here, because we don't want to waste precious time, because we're coming towards a culmination of studies and experiments, and the imagination runs wild. You know what we're talking about, Newton's third. I'm just going to prep it all, okay? All right, so here we are, Newton's third. I had to put that, but not in a vacuum at the bottom, just because we're dealing with common sense here. To every action, there is always an equal and opposite reaction. And I then go ahead and go in brackets, but not in a vacuum. Because in a vacuum, there are no particles, no molecules, no atoms, nothing. So your initial action is not going to work, is it? There's no... How can there be an opposite reaction to an action that has taken place in the vacuum of space? Now, it's all very well and good to quote Newton's third, every action is equal to reaction, every time we mention thrust in a vacuum. But it surely defies common sense. Well, it does, which again is probably one of those a trail of little reasons why people were told to dump one's common sense in the name of science and everything good. There can be no opposite reaction to anything that takes place in a vacuum. How have people even come close to contemplating that there is an opposite reaction to an action that takes place in a vacuum? No particles, no molecules, no atoms, sound. Doesn't travel. There's no action. No actions can take place in a vacuum. Now, but they can, came the cries. The moon landings. Who said that? Who said that? The moon landings. You mean the 6 of them between 69 and 72? Those moon landings, they did not happen, folks. It's purely a lack of common sense and a slight detachment from reality. From your reality, not from my reality. How many minutes are we on? We wouldn't want to go over time, would we? This, if you haven't noticed, is just bollocks. A body at rest stays at rest, and a body in motion continues in motion at a constant rate in a straight line unless acted upon by an external force. Well, look, those are at rest. I moved them. We can't do the whole vacuum thing where something carries on. We've got this little thing dancing around, haven't we? I mean, it's going to keep dancing around until it's denser than the medium that it is in. So it's trying to drop to the bottom, but I have string. So what will eventually happen, because of the density buoyancy factor, where it is trying to obviously, it is denser than where it's at. And it will eventually just go, everything will stop. And then it will stay like that until either the wind or I come along and give it a little tweak. Newton would have been proud, wouldn't he? The absurdities. I would like evidence that Newton was real. That's what I'm requesting. Because gravitational, laws of gravitation, but the moon and the tides, the moon has nothing to do. It cannot have anything to do with the movement of agua on planeta Tierra, porque no hay, how do you say pattern in Spanish? Ooh, I'm getting old. There is no pattern to be found, folks. There isn't, and anybody who has taken the time, those people that keep giving it this, it's only because you haven't done the research. It's the same as the flat earth. The people that go, it's round, it's because you haven't stopped. Look left and look right and then cross the road. Everybody's just crossing the road like this, aren't they? You're crossing the road without looking, without thinking. You're just crossing the road. You need to stop. Look left, look right. Look left and look right once more. If it's all clear, you've worked things out for yourself, then cross the road. You don't run across the road because everybody else is running. That way, people get hurt and people don't realize that they're following other people who are clueless also, aren't they? Now that is law 1, 1b, 2c, right? And every action has an equal and opposite reaction. It cannot, though, in the vacuum of space, because the initial action simply cannot happen, folks. Now, I'm just going to pause you once more. And guess what? I procured a prism from eBay. That took a couple of weeks to get here, and then I lost it twice and found it 3 times, which is why we are seeing the reflection of said prism, where the sun is bouncing through it. Because Newton, he procured himself a prism back in the 1600s. And the question does remain, where did Newton procure a prism from? A prism, of all things. He procured himself a prism, and I then, with other prisms and stuff, paraphernalia, he worked out all of the colours of the spectrum and came up with all of this stuff in between the gravitational stuff and the motion, the laws of motion, which are all horseradish. They're all common sense, apart from every action has an equal and opposite reaction, but not in a vacuum, because that defies common sense and logic. But that's what we go for here on Earth nowadays. We don't think before we cross the road, we just run along with everybody else. Safety in numbers. The car will hit somebody else, won't it? Won't hit me. All right, folks. Red, orange, yellow, green, blue, indigo, violet. Newton. Mi culo, Newton. Laters.